How do we calculate the distance between a point and a plane? Well, remember that in two dimensions, the analog would be the distance between a point and a line, and that is the orthogonal distance. So we're not going straight down, we're not going straight to the right, we're going diagonally in a way that this is perpendicular. So orthogonal, again remember, meaning perpendicular. In 3 dimensions, the distance between a point and a plane is still the orthogonal distance. So I have a diagram where you see here's a plane, and then this blue point, if we wanted to measure the distance there between here and the plane, we want to find that distance. We want to be able to say this is the distance between it. We don't want to go straight across or straight up. We want to go perpendicularly. So in order to do that, we want to find what a perpendicular vector is as part of the process. Specifically, we're going to use a perpendicular vector, a normal vector n, and say that the distance between a point P and a plane orthogonal to vector n is QP, the vector QP dotted with n over the magnitude of n, where Q is any point in the plane. So we can pick any Q in the plane, and it should work. So let's find the distance between these two. Well, first of all, let's say that we should find a normal vector. A normal vector would be 2, -3, 1. We also want a point Q, and that point, we can pick anything. What I'm going to do is I'm going to substitute in 0 and 0 here. So if I substitute in 0 and 0, I get z plus 4 equals 0. So 0, 0, and then the z coordinate would be z plus 4 equals 0, so z equals -4. You could have picked a bunch of different points and it would still work. That's the point that I'm using. You can pick whichever one you want. And then this is going to be our point P. Now we find out what QP is. So that will be -12, -12 minus 0, 0, 0 minus 0, and 5 minus -4 is 9. So that's going to be our distance. That's going to be our vector from Q to P. And now we take the dot product, the absolute value of the dot product, over the magnitude of n. So this is QP, vector QP, dotted with vector n. So let's write that out. Vector QP is -12, 0, 9. Dot that with, what was the vector? 2, -3, 1. All over the magnitude of 2, -3, 1. Now, in order to dot these, we do -12 times 2 is -24. 0 times -3 is 0. 9 times 1 is 9. And in the denominator, we're taking the square root of 2 squared. 3 squared. I'm just bothered by the way that this is the trackpad I'm using is skipping. And that's -24. -24 plus 9 is -15. Over square root of 4 plus 9 plus 1, 15 over the square root of 14, and type that into a calculator. 15 divided by the square root of 14 is approximately 4.01. So that is the distance between the plane and the point. Let's do another. So how far is this point away from a plane with this equation? Well, let's first find a normal vector. A normal vector would be 6, 1, -4. I'm getting that from the coefficients of the plane. Now the point Q is going to be 2, negative 6, 1. Shush you. These are from the differences inside the parentheses. So vector QP is going to be final minus initial, so 10 minus 2, 2 minus negative 6, and 7 minus 1. Now we want to take the dot product. So the dot product is 6, 1, negative 4. It doesn't matter which order we do the dot product in. Over the magnitude. Oops, I'm taking the magnitude of the wrong thing. It should be the magnitude of the normal vector. So we have 48 plus 8 minus 24 over 36 plus 1, oops, plus squared, plus 4 equals, let's see, this is 32 in the numerator, and in the denominator, that should be 16. 4 squared is 16. That's giving me 53. Typing that into a calculator, we get approximately 4.40 is the distance. One more. You should recognize this problem. A sphere is tangent to xy trace and is centered at negative 8, 2, negative 4. What is the volume of the sphere? So, the formula for volume of a sphere is 4/3 pi r cubed. So we want to find the radius. Well, the radius, when it's tangent to xy trace, means the distance between this and xy trace. Xy trace is z equals 0. So that's where finding the distance between a plane z equals 0 and this point comes up. So this plane is z equals 0. That's the same thing as 0x plus 0y plus 1z equals 0. So in other words, our normal vector is 0, 0, 1, and our point can be 0, 0, 0. So using Q and P, here's P, we can say that the vector is negative 8, 2, negative 4. That should be straightforward. We're doing negative 8 minus 0, 2 minus 0, negative 4 minus 0. And now we apply our formula. So it is QP dotted with the normal vector over the magnitude of the normal vector. So QP 8, 2, negative 4, sorry, negative 8, 2, negative 4, dotted with 0, 0, 1 over the magnitude of 0, 0, 1. The numerator becomes just absolute value of negative 4. The denominator is square root of 0 plus 0 plus 1. So this is 4 over the square root of 1, which is 4. It's a coincidence that all of these are about 4 away, but that is the radius of the sphere. So now, what's the volume of the sphere? We can plug that back in. For the volume, 4/3 pi times 4 cubed, which is 64 times 4 is 216 pi over 3. So that's our volume of the sphere.